Okay, we are here in video 3 for the final section of chapter 1. You can tell it's the final video because I haven't advanced it yet. This is the final video for chapter 1, section 6. It's the third video of 3. It is going to cover circles, what a circle is, and it's also going to cover area and perimeter of polygons and circles. So we're going to start off defining what a circle is. Now, please note, circles are not polygons. They're curves, but they're extremely important, so we still need to know what they are. A circle is a locus of points, locus being a fancy word for set, of points which are equidistant, which is a fancy way of saying the same distance, from a single point. Okay? That single point is the center. Okay, so down here we have a picture. This is a picture of what we would call circle C. So this is the mathematical symbol for circle. And then we name the center. Okay? So circle C. Now, there are two important measurements to a circle: the distance from the center to the outside, which is known as the radius, and the length of a chord that passes through the center. See the dotted line here? See how it goes through the center, but it connects one side of the circle to the other? That length is known as the diameter. Now, it is worth noting that the diameter is always equal to twice the radius. Always. Alright, now, circles do not have a perimeter. They have what is called a circumference. Essentially what that is the perimeter of a circle. Now, I'm working under the assumption that everyone knows that the perimeter is the distance around the outside of the shape. So since this is not a polygon, it doesn't have a perimeter. It has a circumference, which is the same thing. So the equation for circumference is that the circumference is equal to 2 pi times the radius. Now keep in mind that since the diameter is twice the radius, you could also write that as the diameter times pi. It doesn't matter which equation you use. You should use whichever one you have. If you have the radius, you should use this equation. If you have the diameter, you should use that equation. And then we have the area of a circle. The area equation for a circle is that the area is equal to pi times the square of the radius. So we have three equations here that we would use in an example. There are only two other shapes that we're going to discuss currently for area. Those are rectangles, which would include squares, and triangles. Now, it's very important to note that the big key idea here is that whatever side we're using for the base must be perpendicular to whatever we're using for the height. Now, in a rectangle, that's not very difficult. We've got a base and a height. They are clearly perpendicular because we have this right angle symbol between them. The area of a rectangle is base times height. Now, there is an equation for the perimeter of a rectangle as well, but I would think you'd be able to add up the sides. Keep in mind that there are two bases and two heights. So the perimeter would be 2 times the base plus 2 times the height. Now, with a triangle, notice how each side of the triangle is labeled with a letter A, B, and C. That's pretty standard practice. And notice that the height is perpendicular to side C. That means that C is our base and H is our height. So area is 1/2 base times height. Perimeter, on the other hand, would not involve the height at all. it would simply be the sum of all three sides of the triangle, A plus B plus C. So we're going to do some examples of area and perimeter. One of those examples will be a circle, so we're just going to pretend it says area and circumference, because that's what we'd really be finding. Here we go. So the first shape we're asked to find the area and perimeter of, to the nearest tenth, that is 1 decimal place, is a rectangle. So we would start with the area. Area is base times height, and the base and the height have to be perpendicular. Well, it's a rectangle, so that should be a relatively simple thing to figure out. The base is 3.2. The height is 2.1 centimeters. So that would be 3.2 times 2.1. So the area would be 6.72, which we would round to 6.7. Notice the approximate symbol, square centimeters. The perimeter, if you're not careful, you're going to get caught here. The perimeter, we would add up the four side lengths. You could also use the equation, which would be 2 times the base plus 2 times the height. Or you could do 3.2 plus 2.1 plus 3.2 plus 2.1. Either way, you're going to get a perimeter of 10.6 centimeters. And that is not centimeters squared, because you're finding perimeter, which is a length. So there's only singular units. Okay, the next one here we have a circle, radius of 3. So our area would be pi r squared, or pi times 3 squared, which would be 9 pi. Now, generally speaking, we're going to substitute in 3.14 for pi, which would be about 28.27 square inches. And we are going to round that to the nearest tenth, 28.3 square inches. Now, circles do not have perimeter, they have circumference. So we're going to do 2 pi r. Again, we are approximating, so we're going to plug in 3.14 for pi and 3 for the radius, which would be approximately 18.85 inches, which we are going to round up to 18.9. Area and circumference. Let's do a couple more. Here we have a triangle. Triangles can be tricky because we have to figure out which side is the base and which side is the height. Stand by, there it goes. So again, it's worth noting that the base and the height have to be perpendicular. So if 8 inches is the height, then the base is 10.2. The other two sides would be A and C. It doesn't matter which one is which. So the perimeter, or the area, is 1/2 base times height. That is 1/2 times 10.2 times 8, which would be 40.8, which doesn't require us to round because it's already to the nearest tenth. So 40.8 inches squared. The perimeter, all we do is add up the three sides, A, B, and C. So that would be 9.5 plus 10.2 plus 9.5. Again, that doesn't require us to round either. We would simply add those up and get 29.2 inches. Now, triangles can be all kinds of shapes. Again, the key is that we know that the base and the height have to be perpendicular. So here we have an obtuse triangle, and it's got a marked height of 8 feet. Now notice how I have to extend the bottom of the triangle, but when I do, you notice that they would be perpendicular, the height and the base. So 5 feet is going to be your base. Again, the other two sides, it doesn't matter. One is A, one is C. So our area would be 1/2 base times height or 1/2 times 5 times 8, giving us an area of 20 square feet. And our perimeter, we're just going to add up the side lengths. There's nothing tricky to it. That is 12 plus 5 plus 16, or a perimeter of 33 feet. That does it for the notes for Chapter 1. The additional videos in the playlist are covering the solutions to the chapter review, and they will not be posted until closer to time for the test.